Hello, everyone, and welcome back to another episode of the Futurum Tech Podcast. I'm your host, Ron Westfall, Research Director and Senior Analyst at Futurum Research. And in this episode, we're going to be talking about automotive Ethernet switching technology. We're going to be talking about software-defined vehicle innovation and so much more here with my esteemed colleague, Amir Barniv of Marvell Technology. Good day, Amir. How's it going?
Oh, great, Ron. Thank you very much. Great. Thank you for having us, in this important episode and looking forward.
Naturally, I couldn't agree more. And I have no doubt that folks out there are keen to know more about you and Marvell's portfolio strategy in the automotive segment. Can you tell us about yourself and about Marvell's automotive group?
Sure do. So I'll start with myself. I'm the Vice President of the Automotive Business Unit in Marvell. Joined Marvell about 4 years ago with the acquisition of Aquantia. And maybe a little bit on the history of Marvell in automotive. So Marvell started to do product for automotive in the 2005 time. They did some storage, they did some Wi-Fi, but these were all opportunistic. Everything changed in Marvell with regard to automotive when Matt Murphy joined the company in 2016 as the CEO. Matt has had a lot of experience in the automotive industry, and he understood the potential. So very quickly, he decided that automotive need to be, a major part of Marvell products. He hired a highly talented general manager, Will Chu, that ran this group, and everything after then, it's all history. Right now, it's the fastest growing business in Marvell, and we are aiming to become the biggest in-vehicle network semiconductor company in the world in the near future. In Marvell, we have the new brand name called BrightLane, and under this brand name, we are developing today the Automotive Ethernet products, switches, PHYs, and bridges. But really for Marvell, it's all about leveraging technology and IP. And we are planning to leverage other technologies and know-how that was developed in the company related to compute, to storage, to security for future products that we are going to introduce into the automotive world.
I think we are witnessing a major transformation of the automotive industry, such as the rapid uptake of EVs. Now, can you share with us your view of what's going on with this transformation?
Sure do. So I think we're all aware of the big megatrends that are going on right now in this industry. Okay, the electrical vehicle that you cannot even call it a megatrend. It's happening already. It's transition. The whole automotive industry is transitioning in this direction. But then there other megatrend like the autonomous car, the connected car, and the software-defined vehicle. But what I really want to talk about is the transformation that we see that more has to do with data and content inside the car. So until 2015, the average car was what we called device-centric. In those cars, we used to have the devices like GPS, like the CD and the radio. Okay, each one was totally autonomous with its own controller, very low share of information between those devices. Starting in 2015, and as a matter of fact, it's going all the way to 2025, we are now moving to what we call application-centric cars, where we have applications that unite under them many different functions. So for example, infotainment. Okay, where you have the GPS, the audio, the content that is downloaded to the car, CarPlay or Android that are used as the operating system. We have the ADAS that is used for lane departure, lane keeping, and then the dynamic cruise control or automatic braking. So these are applications that, again, develop all the different functions that are needed to serve this specific or unique target in the car under this application. But from 2025, we are moving now into a different type of cars that we called data and software centric. These are the cars that has the hardware, meaning the processor, the storage, and the network that enable to download new application into the car over time. Okay, this is the whole premise of software-defined vehicle. You know, that's a buzzword that everyone now is using. And with that, we see a major change in the way the car is being architected and being developed, and the amount of hardware, the hardware content inside the car that is needed in order to support this transformation.
Now, Amir, you mentioned software-defined vehicle. That just jumps right out. From your perspective, is this a real trend, or is this just wishful thinking on the part of the car manufacturers and the OEMs out there?
Very good question. So maybe first we'll explain what software-defined vehicle is all about for the listeners that are less familiar with it. Unlike the cars of today, what we call the traditional car that you buy from the dealer that already include all the capabilities and the applications and the features in the car when you buy it, the future car or software-defined vehicle will enable to download over time enhancement or new application into the car when it's available or when the car owner needed them. Okay, so you don't need to pay everything on the day you buy the car. You can add more features, when you need them and when they are available. We believe that this is going to be a very successful trend because all the stakeholders that are involved in this transformation enjoy it and gain from it. To start with, it's the OEM. For the OEM, it's a new stream of revenues, okay, that don't exist today in the car that they are selling out of the door. The size of this market is estimated to be in the range of $450 billion, okay, for software that can be downloaded over the air into the car. And obviously, every OEM want to take share of this, huge amount of revenues. In addition, for the car owner, okay, it's a very important feature and capability because it helps them to keep the value of the car over time. Okay, so you can a year later or 2 years later or 5 years later download new application, and then you have the value of the car maintained and keep and reduce the degradation of the value of the car over time. And then it's the provider of the content to the car, the service provider, that they really enjoy the high bandwidth that will be needed in those cars in the future in order to better serve these new applications. So this is what we call the win-win-win, and that's the reason that we believe that this is going to be a very successful trend in the next few years.
That's great news, Amir. I mean, a triple win scenario is something that everybody can appreciate. And with that, we can drill down to the networking and Ethernet aspects. How does the software-defined vehicle affect the network in the car?
Very good question. So if we look on the cars of today, these cars are characterized by what we call domain architecture. So we have in the car a few domains, like infotainment, like ADAS, like body. Each domain has its own CPU, its own controller, and it's connected to all its agents around the car that are connected with cables directly to this central ECU. So if we think on 3 or 4 or sometimes 5 domains, it means that we had tons of cables running all over the car, back and forth, to connect all the agents of each domain to its central controller. I like to give the example that VW announced a few years ago that on a mid-sized car like Golf GTI, if you take all the cables in the car and connect them back to back, you will get a cable length of 1.5 kilometers. And for the car manufacturers, it means cost, the cost of cable. It means also weight, okay? Those cables weigh a lot, and when you start to talk on EV cars, that means reducing the range of the car with the higher weight. So the OEM start to work on a new architecture a few years back that called zonal architecture. In the zonal architecture, we are dividing the car into zones, and in each zone, you have an Ethernet switch that connect to all the agent of all the different domains in that zone, okay, with very short cables. And from there, we aggregate all the traffic on a single pair, thin Ethernet cable that is really the backbone of the car and can connect all the zones, including the central switch, okay? And here, what we are gaining, of course, it's all network-based. It's including the security that is part of the network now, the Ethernet backbone. It gives you scalability. You can easily add domains, remove domains. So when you're moving from the high-end car to the low-end car, you can decide that the high-end car you have 6 domains, in the mid-size you have 4, in the low-end car you have 2. Very easy to play with it because it's all Ethernet-based. But it also adds a lot of intelligence into the network. For example, the capability to use as part of the zonal architecture, central compute and even central storage that will control all the different domains inside the car.
Well, this innovation sounds very great and encouraging. However, from my perspective, car makers are notoriously slow and cautious. So, what makes you believe that this development won't stall out, so to speak? What is it that's going to be different this time in terms of making the ecosystem more successful and making these innovations effective?
So that's a very good question, because no doubt there is an investment that the OEM need to do inside the car. You know, adding all these switches in the zones. This is something that they didn't have so far. So until a few years ago, it was really a question of if and when, okay, this transition will happen. However, I have to say that there is a very interesting survey that was done by one of the biggest tier one in the world, okay, that shared it with us, and I presented it already in some conferences, that they basically did a survey with about 25 biggest OEM and asked them when you're going to transition into zonal. And in this survey, it shows that by 2026, 60% of the OEM is already moving to zonal architecture. Now, that was a survey that they did on 2021. They did this survey again on 2022. And then they found out that by 2026, 80% of the OEM now said they're going to move to zonal architecture. And by 2029, it was close to 96%. So I think the question of if and when doesn't exist anymore. It's happening right now, okay, as we speak. And we are, of course, gaining from this transition because it means more content in the car, especially for Ethernet. And this is, what the product that we are bringing to the market.
That's just great news that zonal architectures are pretty much going to become across the board adopted by the car manufacturers. And so what does this mean for Marvell? Now, how is Marvell quite simply going to enjoy this transformation?
So first of all, it's really the growth of Ethernet ports inside the car. Okay, what we see right now is that there are more cars that are adopting Ethernet, especially when they're transitioning into zonal architecture. And also the content of Ethernet, the number of ports per car is growing. So overall, this is a very fast growing market for us. We are talking on a market with a number of ports that are shipped to the car industry that growth in the range of about 25%, from now. And if we look on the next few years, we are talking on over 1 billion ports of Ethernet to be shipped by 2025 already, into this market. And of course, this is what Marvell is doing, Ethernet product for the automotive. And if you look on the content per car of silicon for the in-vehicle network, okay, this is our market, we see the growth where it used to be in domain architecture. It used to be something in the range of $30, for a typical car that used the Ethernet product. Moving to zonal, it more than doubled itself. And when we are talking on zonal, that also including the software-defined vehicle promise, all the hardware that is needed for that, we are talking way over $100 per car, okay, for Marvell type of component for the in-vehicle network.
Amir, that sounds like such a big market, and it's clearly growing fast. Now, I'm expecting a lot of competition for Marvell. So from your perspective, how does Marvell maintain its leadership in this dynamic market?
So I think we need to start, first of all, with the baseline, okay? This is the Ethernet technology that has been used for automotive. Marvell is doing Ethernet product for more than 25 years. So today we have more than 1,000 engineers just developing Ethernet technologies and IPs that we are leveraging for the automotive market. We have in Marvell more than 2,000 patents just for the Ethernet, okay? That of course is very important part of our IP portfolio. And then it's all about the portfolio. We have now the full portfolio for our customers, including switches from low, mid, and high port count, PHYs that run anywhere from 100 megabit to 10 gigabit per second, and then soon we're also going to have 25 gigabit per second. This is what we call the one-stop shop for our customers, that we can give them any product that they need in order to build the next generation in-vehicle network. But this is also related to the strategy, okay? Marvell's strategy is to be first in the market with the important technologies for our customers within the next few years. So we were the first one to introduce secured switch in the automotive market. We were the first one to sample the gigabit 1000 base T1 PHY. We were the first one to sample 10 gigabit base T1 PHYs. And we were the first one also to introduce last year the camera bridge, okay, which in the future will enable the cameras in the car to run over the automotive Ethernet backbone.
Well, speaking of new Marvell portfolio offerings, you just introduced a new central switch, the MV-Q6222. Now, is this another switch for the zonal architecture? What can we expect from this new offering? Yeah,
it is. So this switch is a central switch, okay? As a matter of fact, there is two products in this family, the 6222 and the 6223, which are the 60 gig and the 90 gigabit per second bandwidth switches that we just introduced into the market. And again, being first in the market to introduce such a high bandwidth switch for the central of the zonal architecture. This switch is, I think, more than twice in bandwidth than any other existing switches in the market today, right? And it's aiming again to be the central switch that connects between all the zones. So when there is information that needs to be sent from one zone to another, it's done through the central switch, but also aggregate the traffic from all the zones into the central SoCs like the ADAS and infotainment. And this is a switch that we just announced, and we are sampling it to customer already.
Yeah, the timing of the new switch is most welcomed because with the increased complexity of the hardware and software in the cars, and there's also major concerns related to security. So in this important regard, what is Marvell doing to mitigate these risks, to take care of the security concerns that are out there?
Excellent question. Security obviously is a major concern of the OEM and the tier one moving forward, especially with cars that, the SDV car, software-defined vehicle, that will enable to download new application into the car. So maybe we start first talk on the attack vectors, okay, that we see right now in the car that has to do with the hardware, which is what we are bringing into the car. So in a typical switch, you have the capability to program the switch behavior inside the car over the air. Okay, so when we're talking on software-defined vehicle, everyone is talking on the new software for the CPU, for the central processing. But in many cases, you also want to change the behavior of the network to better serve the new application. And this is where you need to update the firmware inside the switch. And you do it through external flash that is connected to the switch, where we are going to download new firmware. And we need to be able to authenticate, encrypt and authenticate the content of this firmware to make sure that, hackers will not try to download, malicious or firmware that really manipulate the behavior of the switch and create risk hazards inside the car. So this is the first attack vector, and we are doing it already in our switches, authenticating the firmware. The second attack is really related to the device authentications inside the car. Okay, when the switch is connected to all the devices, you want to make sure that none of them, again, is a malicious device that's somehow inserted into the car. So the switch has the capability to authenticate all the devices that are connected to it and basically disconnect from those that it cannot authenticate and doesn't understand the source of this device. And the last one has to do with the data exchange, okay, that is going inside the network, that again need to be authenticated and encrypted, okay, to make sure that hackers cannot access this data, okay, with means like man in the middle or replay of packets. There are many mechanisms that are, can prevent the network to behave as it should inside the network. And we should protect ourselves from all these, vector attacks. So in our switches, we already implemented a very important feature called MACsec. MACsec, it's an IEEE feature that's already been proven on millions or maybe billions of ports in the data center and enterprise. And now we are leveraging this for the automotive. This is a standard feature. It's developed in IEEE, and this enables to authenticate and encrypt data that are running between our switches to our PHYs on the other side. So in Marvell, all the PHYs and all the switches now include MACsec. In addition, in order to be able to encrypt data, you need to make sure that you have keys, okay, that you are using in order to do the encryption. You don't want to download these keys from the outside of the car, because then hackers can find ways to access those keys. So in our switches, we have a module called HSM that is generating and distributing the keys to all the devices inside the network. And then the third layer of protection has to do with internal hardware that's called TCAM. That is a hardware that can filter the data, okay, that can monitor, do what we call deep packet inspection on the packets that are running inside the switch. And by that, they can do what we call whitelisting or blacklisting, meaning identify some addresses from devices that are not recognized and then disable all traffic from those devices. So all these features, the MACsec, the HSM module, and the TCAM are now part of our new generation of switches and are there in order to protect, the car from hackers and other type of threats.
Yeah, the Marvell security protections are essential. It's something that all the car manufacturers have to have. So this is good to know that Marvell is making this very important contribution to the ecosystem. And with that in mind, Amir, beyond the current changes that are going on in the car network, is there any additional future potential growth for Ethernet in the vehicle itself?
Excellent question. The way I see it, this is only the beginning, because what we talked right now is on all the different components in the car that we are connecting through the zonal architecture, like actuator, like infotainment, some ADAS capabilities. But there is the next level of components that are not connected yet through Ethernet. For example, the cameras. Cameras are today connected point-to-point directly to the SoC devices, okay? And the reason is that camera traffic is very high speed. This is uncompressed video from the cameras in the speed of multi-gig. And Ethernet, until lately, I would say until a few years ago, didn't have enough bandwidth in order to support these high-speed traffic from the cameras, the video. However, with the new introduction of 10 gigabit Ethernet, and in the near future, there are also going to be 25 gigabit Ethernet links inside the car, now you can drive the camera output directly over Ethernet links and connect them directly to the zonal switches. So that's one new area that we're going to attack in the near future that's going to add a lot of content for the Ethernet inside the car. The other one is the displays. Display is again, another driver of very high content, very high speed video inside the car. And today, again, they are connected with some point-to-point legacy technologies. And now Ethernet is also going to replace this connection inside the car. So all the displays, and we are talking in the future cars anywhere between 3 to 6 displays in the car. and all of them will be connected through the Ethernet network. On top of it, it's the storage, okay, that right now it's distributed for all the ECUs, and in the future, it will be central storage that is Ethernet-based and connect to the network, and everything will be connected to this storage inside the car. So the growth and the future of Ethernet in the car is still going to be very big, and again, for us, very attractive market to go after.
Well, that just sounds great. The future is definitely looking up in terms of automotive Ethernet innovation. And on that positive note, thank you so much, Amir, for joining our webcast today. And
Thank you very much.
No problem.
Thank you very much, Ron. It was a pleasure talking to you, and hopefully our audience will find all this information interesting and intriguing.
I believe so. And that's a definite thumbs up. Looking forward to another conversation in the future. And with that, everybody, thank you so much for tuning into our episode. Hit that subscribe button and join us for all of our shows here on the Futurum Tech Podcast. We appreciate you all tuning in. And for this episode, thank you so much. We'll see you all later.